Shifting the gears to the next session, future of urban mobility. Stay with us as we delve into this critical aspect of futuristic transportation system. I invite Professor Ashok Jhunjhunwala, President IIT Madras Research Park and Incubation Cell, to share an introduction regarding the same.
The primary reason for something like this, it's a new technology that we are proposing here, is that today in city of Chennai, to come from your office to home, it is starting to take anything like 45 minutes to an hour, 15 minutes. For most people who are driving, 45 minutes to an hour, 15 minutes. Return, again similar time, maybe more, depending on the time that you leave. What does it really mean? 2 hours to 2.5 hours of driving time every day. Is this India's future? Is this what India will see going forward? We are talking about becoming a $1 trillion economy or things like that. And as more and more people from rural areas come to urban area, there will be even more congestion. And they are mostly coming to large metros, large cities. So it is Bangalore, Chennai, Delhi, Bombay, Hyderabad, all of them are facing similar kind of problems. Of course, what is the way one can do that? It's of course highly polluting. Even if you replace this by electric vehicle, the time 2 hour to 2.5 hour a day will not reduce. For last 8 to 9 months, we have been working on, is there an alternative solution possible? Can it be a green solution? Can it be a solution that can be implemented in today's cities? Can this solution make business sense? We have been on it for some time, and very fortunately, we have come up with most of this solution. And I'm going to introduce that and then follow up with a panel. We are calling this solution hashtag, high throughput, because cities like Chennai or Bangalore require very large number of people to be moved. Autonomous. We are talking about totally autonomous vehicle. How? We'll look at it. We are talking about sustainable. So it is to be highly sustainable. Only green electricity. It could be for human and goods transport. For the city, we are looking at human, and a similar solution we are looking for the country for goods transport, for the transportation for India's next century. And here we are going to showcase the urban mobility solution. So most of us, it is not that the distances are large. Most of us live within 15 kilometers from our office. But this 15 kilometers is taking an hour, 15 minutes. We are saying, I want to get to my office in 20 minutes. In a comfortable manner. Is it possible? We are coming with a solution, autonomous, personalized pods. We are talking about a very comfortable solution. Personalized pod travel without stoppage. It doesn't stop at an average speed of 75 kilometers per hour. If we can get there, we can get 15 kilometers in about 10 to 12 minutes. And 15 to 20 minutes, we can get from home to office. The 75 kilometers is average. It can slow down to 50. It can go up to 100 kilometers per hour. But there is no crossing and no stoppage. I think that's the crux of the problem. It will never stop. It will pick me up and then just keep moving. It will slow down a bit occasionally, speed up a bit, between 50 kilometer to 100 kilometer, average of 75 kilometer, no stopping, this thing. And must be built on today's Chennai or today's any city. What are we talking about? We are talking about a public transportation system, but personalized public transportation system. So what will happen? First of all, there has to be a station fairly close to my home. 300 to 400 meters, 500, 300, 400. I should be able to walk in 3 to 4 minutes. And similarly on the other side, from near my office, again 3 to 4-minute walk is what I'm talking about, no more than that. And there is an origin station and there is destination station. And then I should travel this 15 kilometer in 12 minutes, less than 12 minutes, no stopping. And this is what we are talking about. Idea is, I will have on my mobile phone saying I want to go to such and such place. I book, a pod will be booked for me. I will have several stations close to me, not one. Within 400-500 meters of my walk, I probably will have 3-4 stations. We'll talk about how. And it will say, go to this station, a pod is waiting for you. It will give me even the route on the map. So I should just walk there. Walk to the nearest station within 400 meters. The pod will be there ready for you as you arrive. You get inside a pod, sit inside, comfortable, air conditioned, nice pod. 2 people can sit in a pod, and this will carry you to your destination. And in 12 minutes. And then again, of course, you have to walk. Now, is it sustainable and cater to future needs? It must be powered by green electricity, no other power. That is what we have assumed. So green electricity basically means that Milinda has to give us enough solar and wind so that we can have a green electricity, 100% green electricity, and should do. But what about sustainability and cater to future needs? So first, it is not just the green electricity, but it has to be energy efficient. We have, for example, in this conference, a talk on heating and cooling. We are saying energy efficiency is very, very important. And therefore, we started looking at energy efficiency. If a vehicle travels on road, it has a frictional resistance that the road provides. It travels on rail, the energy required is 1/10. Because rolling resistance is 1/10. Very simple. So it will be traveling on a rail. So it will be a rail travel. Of course, immediately question, how will we set up those rails? We'll come to that. Then the second energy that it takes, a vehicle takes 2 kinds of energy. Actually, it takes another one. One is the frictional resistance or rolling resistance. Second is aerodynamic resistance. When it pierces through the air, if it's traveling at high speed, it takes energy. That we minimize by saying multiple vehicles traveling on the same rail will platoon, will join each other and then travel. If they platoon, only the front one gets the aerodynamic resistance. Rest get very minimal. So we are able to minimize the aerodynamic resistance at 75 kilometer platoon of 10 users of 11 watt hour, uses only 11 watt hour per kilometer. At 75 kilometer per hour, if it's traveling average, a platoon implies that each vehicle will only use 11 watt hour per kilometer. Today, a e-rickshaw at 25 kilometer per hour uses about 40 watt hour per kilometer. So we are talking about using a fraction of energy. Why are we using a fraction of energy even though we are going much higher speed? Instead of 25 kilometer per hour, we are going 75 kilometer per hour. One, because we are using a rail and we are not going on road. Our e-rickshaw is going on road. Number 2, we are forming a platoon. So only the front one gets the full impact, the rest 9 gets minimal impact. So this is what we are talking about. We are talking about 11 watt hour per kilometer. Maybe, depending on the situation, maybe 15 watt hour per kilometer. That's the energy that we will require. So if I have to go 15 kilometers, what are we talking about? We are talking about 150 watt hour. That's all that, I mean, less than 200 watt hour. That's the energy that we are talking about. Where will it be built? So we are saying on even the smallest lanes of the street, it will be built as on an elevated platform. Now, is that feasible? Elevated platform on a smallest lane. Small lanes, large lanes, it will be elevated platform. It will be at height. And the vehicle is not going to be much wider than an auto. So we are only talking about this vehicle, much size vehicle. 2 people can sit. So a rail at a height, it will be moving on that. And there will be a north-south and east-west rails. And there will be at 2 different levels, so they will not cross each other. The only thing that you can do is enter the rail, that rail, or exit on the rail. When you enter the rail and exit the rail, the speed will go down or go up, go down. Otherwise, you will keep traveling straight on the rail. There is no crossing at all. If you want to go from north-south to east-west, well, you get down on the north-south and go on the east-west. That will be provided. The vehicle will slow down a bit, not very significantly. Seamless integration with existing infrastructure. And it is going to be built on almost every lane. So it will be fairly dense. So we are talking about mesh kind. It need not be exactly a mesh, need not be straight lines. It could be curvature. It will a little bit impact the speed, but not very significantly. So we are talking about that, suppose this is the origin station and this is a destination station. A grid-like rail network at the height of roughly second floor, unidirectional, no crossing. So here it is shown as crossing, but there are 2 different levels. Between any 2 paths, there are large number of paths available. For example, there is a path like this if you want to go from here to here. There is another path which can go from here to here. There is a third path that can go like this. There can be a 4th path. There can be any number of paths. Now, why multiple number of paths are important? Multiple number of paths are important because we will choose a path at the beginning of the journey and say, till the end, this is the path that you will follow. It is getting into the thing at 19.05 and it will reach its destination at 19.17 minutes. And these are the paths at which it will be there. And we will see that not any link, none of the link that it is using, none of the links that it is using will ever be congested. So it will be something that it will calculate how many vehicles at 1903 will be on this link. What is the capacity of the link? If the capacity of the link is 50 vehicles, and if the number of vehicles are already 50, my vehicle will never choose that path. So this will be a pre-calculation done at the time of booking. It's a little bit of exercise, but it can do that. The route is chosen at the beginning, automated path selection to avoid link congestion. It's a sophisticated algorithm. Ensures no track will ever be overloaded. And the number of turns, which means exit and entry. Each exit and entry will have a penalty. So we have said not more than 3 exit and entry. Now we have done all this. We have calculated, we have simulated and seen that you can always find a path for very, very large traffic. Multiple equidistant path, almost equidistant path. So can it scale for all travel in a city? We are talking about 700 meter by 700 meter. Every 700, roughly 600 to 800 meter in a lane, there will be a rail. This side as well as this side. So every 700 by 700 meter grid is like in a 20 kilometer by 20 kilometer station, 2 stations at every cross point. One on the east-west, one on the north-south. So again, 2 stations are there. 6 pods leave a station in a minute. So every 10 seconds a pod is leaving. Small vehicle, get in, and pod is leaving. And pod will enter, stop, you get out on second floor, third floor. Where are we going to build stations? Well, we will build stations in the existing buildings on second floor. One flat will be taken, leased out, taken as a station. Wherever there is a lift so that you can go there on 2 floors and get into the vehicle. So the whole thing will be designed like this. We are talking about 360K pod trips per peak hour. We have computed for this 30 by 30 grid. If the grid is larger, the number of trips will increase. And we are talking about 2.5 million pod trips a day. Pods can accommodate 1 to 2 passengers. More stations can be added in congested areas. We have worked these things out, simulated it, and built it. Most important is we have calculated that actual cost of building the whole infrastructure, pods, taking 10% interest cost, life of the rails and life of the pod, all of them taken into account. Actually, our cost comes to 20 rupees per trip of 15 kilometer. 20 to 25 rupees. That's all. We've done all the calculation. We had civil engineers design the structure. We computed everything. It's a very rough estimate. Maybe we are a little bit wrong. But we are putting a passenger can be charged 50 rupees for a 15 kilometer today. That's the kind of thing that we are talking about. And what we did is that not only we conceptualized it, we simulated it, and then some kind of model we designed. We got some 20, 25, 30 youngsters, 21 year and 24 years, and they build a toy model. The toy model is there in C block in this building on second floor. It doesn't exactly simulate everything, but shows all the important concept. And we were able to actually do this, and we validated that yes, this case is doable. This is what is working. Today, after we finish this session, before dinner, if you want to just go down, somebody will guide you. C block, floor number 1, you can come back again and join for lunch. Or from the 6th floor, you can go and do that. And actually, this is a prototype that is working. What do we do from here? Well, we are validating and validating more and more of it. We want now partners who understand every aspect. The only important aspect is exit and entry. Exit and entry. That part we are reworking and checking it out. And once we do that, we'll actually want to build a prototype, which can actually be a live prototype of full size, which not the 30 kilometer by 20 kilometer by 20 kilometer, but maybe 1 kilometer, we can actually build and test it out. And then the technology can be made available. There is a lot of computation, a lot of careful analysis, but there is no magic, no new technology we are talking about. We are talking about existing motors, existing batteries, existing controllers, the kind of rails that we can today have, material that we are not talking about new material. This is possible today. Thank you very much. And with this, I think we can have there is a small panel on future of urban mobility, and we can have that.